To keep the world's tallest tower from collapsing during an earthquake, Japan had to use a secret weapon, one that was first designed to launch NASA's rockets to the moon.
Okay, so let's talk about the Tokyo Skytree. It stands at a staggering 634 meters tall. That makes it the tallest freestanding tower on the entire planet. But here's the catch. It's built in a city that faces this monumental challenge, a force of nature that literally dictates every single thing about construction in Japan.
We're talking about over 1,500 earthquakes a year. Yeah, you heard that right. Japan sits right on the Pacific Ring of Fire, which is one of the most seismically active zones in the world. So you can imagine, building tall here, it isn't just difficult. A lot of people would say it's borderline impossible.
So that's the big question, right? How in the world do you engineer a super slender structure like this to withstand the constant threat of the ground just violently shaking underneath it? Well, the solution? It's an incredible story that connects ancient wisdom with the absolute cutting edge of the space race.
One of the lead engineers on the project, Atsuo Konishi, said it himself. He said that controlling the swing and the movement of this tower was their ultimate challenge. And the solution, it wasn't going to be found in some dusty old architecture textbook. No, they had to look in the archives of the Apollo program.
So to find that solution, we've got to travel back in time. We're going to the 1960s, down in Florida, right at the height of the space race. Because back then, at the Kennedy Space Center, NASA was facing its own colossal engineering problem. So, this was during the Apollo program, and NASA was getting ready to launch the Saturn V. This was the most powerful rocket ever built. At the moment of liftoff, its 5 F1 engines would generate more power than 85 Hoover dams combined. Just think about that. Every single component had to work perfectly.
And the specific piece of equipment that was causing this massive headache? It was these things, the umbilical swing arms. These giant arms supplied the rocket with all its fuel and power right up until the very last second. And then they had to pull away instantly.
The problem was the sheer violent force of that retraction. These arms could just snap, or even worse, bounce back and hit the rocket just as it was lifting off. A collision would have been absolutely catastrophic. So what NASA needed was a super strong, super reliable shock absorber.
And the answer? It came from a former Air Force engineer named Paul Taylor. This guy was developing all sorts of new technologies for the space program. And his design? Well, it would turn out to be the exact breakthrough NASA was looking for.
So the concept he came up with was called a fluid damper, or a liquid spring. And here's a great way to think about it. Picture a coffee press. When you push that plunger down, the liquid inside resists, right? It's being forced to those little holes. That creates friction, and that friction absorbs energy and slows the whole thing down. Taylor's invention was basically just an industrial-strength version of that, but engineered to absorb just unimaginably violent energy.
So Taylor's fluid dampers were installed on the launch tower, and they worked. They perfectly controlled those swing arms, ensuring a safe liftoff for every Apollo mission. It was an amazing invention for space that was about to find a totally new purpose, right here, back on Earth.
Okay, let's fast forward a few decades. The engineers working on the Tokyo Skytree, they knew all about Taylor's dampers. But here's where it gets really cool. They decided to combine this space-age tech with a solution found deep in Japan's own architectural history. You see, for centuries, Japanese builders had been constructing these incredible earthquake-proof pagodas, and they did it using a central wooden pillar called a shinbashira. Now, this pole was structurally separate from the outer frame, which meant it could sway independently and actually counteract the vibrations of a quake. Pretty clever, huh? So, the Skytree has its own modern shinbashira. We're talking a massive, 375-meter-tall concrete core. But the real genius is how it's connected to the outer steel frame. They used a series of Paul Taylor's fluid dampers. Yep, the exact same technology that helped launch rockets to the moon. This is where it all comes together.
So what actually happens when an earthquake strikes? Well, this unique combination of ancient and modern tech allows the tower to perform what you could almost call an elegant life-saving dance.
Okay, so here's how it works. During a quake, the outer steel frame, which is lighter, it sways pretty quickly. But the massive inner concrete core, it moves much more slowly. So they're essentially moving out of sync with each other. And this difference creates a powerful counteracting force. And those oil dampers, placed right between them, they absorb all of that opposing energy.
It's brilliant.
Think of the dampers as the ultimate buffer. Their whole job is to prevent that gargantuan inner core from slamming into the outer structure. Because if that happened, it would cause a catastrophic failure. Simple as that.
And the result? Well, it's one of the most resilient, super tall structures ever built. I mean, the technology that was born from the explosive power of a rocket launch now provides this silent, steady protection against the immense power of the Earth itself.
Just how effective is it? The system reduces the tower's vibrations during an earthquake by up to 50%. 50! I mean, that is literally the difference between the tower standing strong and just total collapse.
It's just this incredible full-circle moment for innovation, isn't it? The very same technology that helped propel humanity to the moon is now the thing keeping one of our greatest modern monuments anchored safely right here on Earth.
And it really makes you wonder, doesn't it? What other world-changing technologies are just hiding in plain sight? You know, things that were born from solving one problem, but are perfectly suited to solve another one we haven't even considered yet. It kind of suggests that the next great breakthrough might not be a brand new invention, but a rediscovery.